everyone, I hope you are all doing well. Today we are going to add on some weight to strengthen our brain with algebra. Just like anything in life, the only way you get stronger is by working hard. So we're going to do the same thing with our mind for algebra. So today's video is going to talk about adding and subtracting rational expressions. So just to go over a little review, remember that when you're adding or subtracting fractions, you need a common denominator. So if you do have a common denominator, you just go ahead and subtract or add the numerator, whatever the operation is, and you keep the denominator the same. Okay, so we just focus, once we have a common denominator, we just focus on the numerator. All right, so if you look at example 2, we do not have a common denominator here, so we have to do some preliminary work. One way to find the least common denominator is to start listing out multiples and see which one they share in common first. So 5, 10, 15. So 15 is going to be our least common denominator. So if we focus on this first denominator, basically how do we get 3 to look like 15? Or another way to think about it is take 15 divided by 3, which is going to be 5. So we're going to multiply this by 5 over 5. Remember that whatever you multiply the numerator by, you also have to multiply the denominator by. And then how do we get 5 to look like 15? That means we're going to multiply by 3 over 3. So we have 25 plus 18 over 15. Okay, you can go ahead and combine the fraction like that since you're working with the same denominator now. And you get 43 over 15. That can't simplify at all, so you're done. Okay, so that was just a little warm-up. Now we're going to actually do that with rational expressions. So the first thing you need to ask yourself is there a common denominator? Okay, if there is a common denominator, you can go ahead and go right to step 2. If there's not, we got to do some work, which I will show you guys in a little bit. So step 2 is going to be to basically combine like terms in the numerator. So you're going to simplify the numerator. Okay. And notice that I said step 2 comes before step 3. This is a huge active note. You must simplify the numerator before you try to simplify. Okay. Oftentimes, students will do step 3 before step 2 when we're working with unlike denominators. But step 2 must come first. You must get everything combined on the numerator. So, you should only see x once. You should only see x squared once, whatever you're working with, before you try to simplify. All right, so let's take a look at our example. We do have the same denominator. So we're going to go ahead and simplify the numerator. So that's just going to be 5 plus 7, which is 12. Okay, now since I did step 2, I can go ahead and ask myself, can I simplify anything? Which I can. This is just going to be 4 over x. Make sure that you keep x in the denominator. All right, let's look at example A. So the first thing you ask again is, do you have common denominators? Which we do. So we're going to go ahead and focus on the numerator. We're going to combine like terms. So that's going to be 3x plus 3 all over x plus 2. Okay, and then at the end, you should always ask yourself, can you factor, simplify, which we can take a 3 out of the numerator, but nothing cancels. So in this example, either answer is acceptable. Some students like to factor it regardless, just to make sure that nothing can cancel at the end. Just looking at this problem, I knew it wouldn't cancel, so I could have left my answer like this. Okay. All right, let's take a look at one more example on this page. So ask yourself, do you have a common denominator? Which we do. So we go ahead and combine the numerator. So that's going to be y plus 3 over y. Okay, just like I've been stressing in all of our videos in this unit so far, do not cancel these y's. This y plus 3 is attached, and if you want to, put parentheses around it so you make sure that you keep it together. Next page. So really the only difference about this is that now we're working with subtraction. So every time you're working with subtraction, I always tell students to put parentheses around what you are subtracting. So I'm going to go ahead and put parentheses around the x plus 5. And we've done something similar to this before. Okay. Then step 2 is going to be the same thing we did on the previous page, just in different order now. So ask common denominator. Okay, in this example, we do have a common denominator, so we can go ahead and go on to step 3, which is combine like terms in the numerator. And then my last step is going to be simplify if need be. Okay, once again, make sure that you do step 3 before you do step 4. All right, so we put parentheses already around what we are subtracting. We have a common denominator, so we can go ahead and simplify the numerator. So this is going to be 3x minus, in parentheses, x plus 5. So all over the least common denominator. Okay, do not cancel anything. We need to simplify the numerator first. We have 2 x's showing up in the numerator, so I know I'm not done with my work. So 3x minus x minus 5. 2x minus 5 all over x minus 1. Then ask yourself, can anything simplify? Which in this case it cannot, because remember that these are attached, so we are done with the problem. Okay. All right, let's go to example A. So we have subtraction, so the first thing we're going to do is put parentheses around the numerator, so we make sure whatever we're subtracting. Then we ask ourselves, do we have a common denominator, which we do. So then we're going to go ahead and simplify the numerator. So 4x plus 1 minus 2x minus 3 all over the least common denominator. Again, do not do step 4 yet, or in other words, the last step. You must simplify the numerator first. So 4x plus 1 minus 2x plus 3. So that gives me 2x plus 4 over 2x minus 1. Now in this problem, just like we did on the previous page, you could actually leave your answer like this, but you can take a 2 out. It's just that nothing cancels with it, so that's why you can leave it as either answer. These 2's cannot cancel because there are parentheses here. You can't break them up. Okay? All right, so now we're going to focus on what happens when you do not have a common denominator. So we're going to start off by just practicing finding least common denominators. So when you're working with numbers, basically start listing the multiples out. So this is going to be 4, 8, 12, and so forth. Okay, and then this is going to be 2, 4, 6, and so forth. So the first one they share in common is the 4. So my least common denominator, my least common multiple is 4. Okay. All right, let's go on to the next example. This is going to have a little bit more work in it since there's variables in it, but we're going to approach it the same way. So let's start listing out the multiples of 4. List out the multiples of 3. And you will see that the first one they share in common is 12. Okay. And just like you would for the numbers, you do the same thing with the variables. So you start listing out multiples of r. So r to the second, r to the third. Okay, and then this one would be r to the second, r to the fourth, r to the sixth, and so forth. So which one do they share in common first? R squared. Okay. Another way you could look at it is basically you have to take the highest exponent of the same variable. So if we look at this, r and r to the second, you take the highest exponent of the variable. So we would take r to the second. If we had, let's say, x to the first, x to the fourth, x to the sixth, you would look at all of that and take the highest one, which would be x to the sixth. That would be the first multiple they shared in common. Okay. All right, let's go ahead and take a look at example 3. Notice we actually even have more preliminary work to do on this one because we have to factor this denominator. Okay. And basically you look at each set of binomials. So you have x minus 3 as one, and then you have x plus 3 and x plus 3. And basically the same rule applies. You take the highest exponent. So looking at x minus 3, it only shows up once. So that's going to be x minus 3 to the first. And then we do have x plus 3 and x plus 3, but this is only to the first. So take the highest exponent. In this case, it's exactly the same, so you would do x plus 3. Okay, do not put two sets of x plus 3. You wouldn't do that with numbers. You wouldn't put a 4 and a 4. You just take 4 because that's what they share in common first. Okay, so what I mean by that basically, and I know it's kind of redundant, but if you have 1/4 and 1/4, I know those are the same denominator, but if you were to multiply them together, that'd be 16. That's not the first denominator they share in common. 4 would be the first one they share in common, which is why you don't do x plus 3 twice. Okay, let's get into one more practice example and then we'll move on. So at first sight, this doesn't look like it'll be the same denominator, but this needs to be put in descending order. And then take the negative out. And when you take a negative out of the denominator, you're going to assign it to the numerator. Okay. And now you have the same denominator of just 3x minus 5. So be very careful of those denominators not being in descending order. And then you can just take the negative out, assign it to the numerator, and voila, you have the same denominator. All right, let's go to the next page. Okay, so as you can see in these examples, there is not a common denominator, so we first have to find it. Okay, and when I'm looking at your work, when I grade it, I'll be looking for you to write the least common denominator off to the side so I can see where you started. So looking at the numbers, the first one they share in common is 6, and then just k to the first. So we have to decide, what do I have to multiply this first fraction by in order to get it to look, the denominator to look like 6k. So one way you could do that is to take 2k and multiply it by something to equal 6k, or the inverse of that, of 6k divided by 2k equals 3. So I have to multiply both top and bottom by 3/3. And then I have to do the same thing with the other fraction. So 6k divided by 3k equals 2. So I have to multiply top and bottom by 2/2. Okay, so we multiply by missing parts, and now I have to make sure that I simplify the numerator before I do anything else. So I'm just going to go ahead and circle this to make sure that we're doing that first. So this gives me 9 plus 10 over 6k. Okay, now combine the numerator. 19 over 6k, nothing can cancel. One common mistake that students make is that they try to cancel this 9 and the 6. You're not done combining like terms here. You have to do that first in order to see if you can simplify afterwards. Okay? All right, let's go ahead and take a look at example 2. So this is one of the ones you got to be careful of. I can go ahead and rewrite this. So the x comes first. I take out that negative, and then I'm going to assign the negative to the numerator. So in other words, I'm going to change this to addition. So remember, assign to numerator, and basically change the operation between the two fractions. So this is going to become addition, and now I have the same denominator. So I can go ahead and just combine like terms. So x plus y plus 2x. So 3x plus y all over the common denominator. I can't do anything else. Okay. So one thing that might help is once you assign that up, you might just want to go ahead and erase it or cancel it. So just maybe put an X through it so that you make sure that you do not include that in your least common denominator. Okay. All right, let's take a look at letter A. Now, some of you might recognize that on this first fraction, you could actually simplify before you even start, but let's just hypothetically say we didn't. So the least common denominator between the numbers is going to be 4, and then you take the highest exponent, so that's going to be w to the third. Okay. So now I need to multiply by missing parts. We didn't write that anywhere up on top, so maybe let's include that. Okay. So in other words, we're trying to figure out what do I have to multiply both top and bottom by in order to get the denominator to look like the least common denominator. So in this case, I'm going to take 4w to the third, and I'm going to divide it by 2w to the third, which equals 2. So I'm going to multiply top and bottom by 2 over 2. Okay. Then I do the same thing over here. So I'm going to take 4w to the third, divided by 4w to the second. That gives me w. So I'm going to multiply this by w over w. So I get 10w minus 9w all over 4w to the third. Okay. Remember, we still have like terms to combine here, so I shouldn't try to do any canceling yet. So this is w over 4w to the third. Now that the numerator is simplified, I can go ahead, cancel these out. That stays in the denominator, so 1 over 4w squared. Okay. All right, I've got 3 more examples for you, 2 on this page, and then we're going to just do 1 example of on the next lesson. Okay, we're not going to do all the next lesson. They're way more complicated, addition, adding and subtracting rational expressions. We're just going to save that for when we are together. So let's go take a look at example B. So hopefully, you're starting to recognize that, hey, maybe when these aren't in the right order, I might have opposites. So I'm going to go ahead and change that and take out the negative. I'm going to assign it up. So I'm going to change this to subtraction. Notice now I have the same denominator. So I can just go ahead and add the numerators or subtract them in this case. So 6y minus 10 over the least common denominator. See if you can factor anything, which we can. We can take a 2 out. And in this example, we can actually cancel further, and we are left with just 2. Okay. So just change the operation between the two fractions. All right. Last example for these notes. So remember that when you're finding the least common denominator, you take the highest exponent of each factor that shows up. So m plus 7, that's just going to be m plus 7 to the first. And then we have an m minus 2. Okay. So this fraction on the right actually doesn't need any work because the denominator already matches the common denominator. But the one on the left is missing the m minus 2. So I need to multiply this by m minus 2 over m minus 2. Okay. So we're going to go ahead and combine the numerator. So this is going to be 4m minus 8 minus 3m. So m minus 8 all over the least common denominator. And you're done. You don't have to do anything else. Okay. All right, so go to the next notes, and it says 15.3 day 2. Like I said, we're only going to do one example. We're going to do B, and then we're going to be done with this lesson. So LCD is going to be y plus 1 and y plus 2. So just take each factor, take the highest exponent of each one. Okay. And in order to get this denominator to look like the LCD, we have to multiply it by y plus 2 over y plus 2. And then in order to get this denominator to look like the LCD, we have to multiply by y plus 1 over y plus 1. Okay? Do not start canceling anything. You need to simplify the numerators first. So y to the second plus 2y plus 3y plus 3. Combine like terms. You still can't cancel anything. And then put this over the LCD. Okay. Now you would have to see if this factors further, which it doesn't. So you're done. So just to recap that problem real quick, how did I get this? Well, this came from distributing the y through to here. And then I got this one by distributing the 3 through here. Okay. Simplify the numerator before you do anything else. If that's one thing you take from this video. Okay. I know that was a hard-hitting video. I appreciate you working through it. We can do this. All right. Thank you.